Hi guys, our topic for the project is endangered fish in freshwater, and we are a team of six. Myself, Manasa. I would elaborate on what the problem statement is. So we wanted to know like what all factors such as mineral compositions, pH, conductivity, temperature affect the marine species. So for that, the variables what we have got from the data sets, what we have collected, are TP, total phosphorus, pH, dissolved oxygen, temperature, conductivity, and nitrate. So we did a statistical analysis on how these various variables affect the living species in the freshwater lakes in the United States. So from the data set, what we got is from the Kaggle, and we have got a lot of columns with null values which are not important. We have removed them and we did a kind of pre-processing. So these are the images which are the dataset values before the pre-processing and after the pre-processing. And the below image shows from the locations from where we have collected the data, various locations in the United States freshwater lakes from where the data is collected from. And coming to the statistical analysis part, so the initial analysis we have done on pH value. So pH is the measure of how acidic or basic the water is, and usually the scale is between 0 to 14, 7 being the neutral. And the acidic value, the pH value is less than 7, and the basic water pH value would be greater than 7. The data set what we had had the pH value ranging from 6.04 to 9.5. With increase or decrease in the pH value from the neutral, the intolerability factor increases. So that is what we have found out from our analysis. And these are the images which shows the pH versus species intolerability and how pH distribution was in our data set. Uh, uh, I'm giving it over to the Megha.
Coming to the total phosphorus analysis, total phosphorus is a measure of all phosphorus found in the sample, that is dissolved or particulate. As the total phosphorus increases, it leads to eutrophication, that is the growth of algae and large aquatic animals, which in turn decreases the dissolved oxygen content in the water. And generally, the natural level of TP is less than 0.03 mg per liter. And also the natural levels of phosphate should be 0.005 to 0.05 mg per liter. And by these observations, we can infer that as the TP increases, it directly affects the life of aquatic animals. So next, coming to the dissolved oxygen analysis, it is one of the most important indicators of water quality, and it is essential for the survival of aquatic organisms. In our data set, usually dissolved oxygen ranges from 1 to 19, and more values are around 8. And in most of the places, the oxygen level is decreased by 2 with the time. And by this observation, we can infer that as the dissolved oxygen content decreases in water, it will affect the organisms directly. And coming to conductivity analysis, conductivity is affected by the presence of inorganic dissolved solids like nitrate, phosphate, sulfate, etc. And it is directly dependent on temperature. And as the temperature increases, the conductivity of the water increases, and it will directly affect the life of aquatic organisms. By this histogram, we can observe the total conductivity of the water. And next, the other components will be explained by Mahendra.
Yeah, hi. Coming to the temperature analysis, we could see this has an indirect impact on the fish's growth. Why? Because when the temperature rises in the water, there is an impact on the dissolved oxygen. So that is one thing which impacts, and even the conductivity increases. So there has been a trend in the change of temperature over the period of time, right from 1995 to the present period. We have captured all the temperature ranges throughout this period, all the different cities from where we have collected the data samples. And these are some of the analysis which we explored when we comparing temperature against the conductivity, temperature against the dissolved oxygen. It clearly shows when when the temperature is getting increased, the conductivity is keep on increasing, and even the same as dissolved oxygen, it keeps decreasing with the temperature increasing. Yeah, so that's how the temperature has an indirect impact on the fish's existence. And next, coming to the nitrates. Nitrates is one of the significant component that is impacting the fish's growth. Why? Because nitrate is required for the fishes and algae growth, but to a permissible limit. If the nitrates present in the water are has crossed that threshold value, it impacts the growth cycle of the fishes. Usually 1 to 40 is the permissible level ppm, whereas we found that the samples we have collected, it is containing more than 80 ppm, which is usually more hazardous, and that is why those it is making the fishes more intolerant to exist in that water bodies. So I'll pass it on to Charan for further analysis and results. Yeah, Charan.
And then getting into the topic of which column is having most impact on the species. Before that, we'll just see how this target column has been distributed. And this curve, we can see that the yellow line is the normal distributed curve, and the red one is related curve to this percent of intolerable species column. So we can see that it is a bit slightly right skewed, and most of the species are less than 25% intolerable. And then coming to see which column is having effect on this. The first one here is total phosphorus. As you can see, more phosphorus levels is going to help the species, by which we can say that phosphorus is one of the good factors. And then one more thing we should be considering is that it should not exceed this 50 units, because more phosphorus in actually it does have an effect, but before that 50 level, we can say that more is going to help. And coming to NO3 column, we'll try to consider the first part of this curve, because we are having more of the data in that part. So in this starting part, you can see the curve is getting increased. So more NO3 does have a strong effect on the species. So it is always recommendable that we need to make sure that there are less proportions of nitrate in the water bodies. And then getting into this conductivity column, you can see that once the curve passes the 40 unit mark, there's not much of a difference in it. So we should always be considering that 40 unit mark. Before that, probably there is some effect on the species. So we should always make sure that conductivity levels are more than 40. And then coming to this temperature column, we can clearly see that more temperature is having more effect on the species. So it's always recommendable to keep the water bodies in cooler temperatures. And coming to dissolved oxygen column, we talk it as it is one of the important factors of measuring the water quality and all, but normally it doesn't have that much effect on the species. It is more or less on the same range. And going to the last column, which is pH, we can see that if the pH range is in neutral, then probably it is going to be the best conditions for the species. And either way, whether it's going to be alkaline or acidic, it is going to have an impact on species. So this is just an overview of what different columns are, how different columns are affecting the species. And then Rodger will take on with some test results on hypothesis testing.
Hi, so I'm going to talk about the hypothesis tests we have done in this project. The first hypothesis test we did was a chi-square test for the null hypothesis that species are evenly distributed across 4 ecological level 3 regions. Therefore, the alternative hypothesis was species are not evenly distributed across 4 ecological level 3 regions. The test results, including chi-square value, p-value, and degrees of freedom, are displayed on the right. Based on such a small p-value for the large chi-square value, we rejected the null hypothesis. The second test we did was a z-test for a null hypothesis that the mean pH value for each state equals the mean of the national pH value. Hence, the alternative hypothesis would be the mean pH value for each state does not equal the mean of the national pH value, which shows the alpha value to be 0.05, and the test results for each state is displayed on the right. Based on the z-value for each state, we rejected the null hypothesis for almost every state except for New Jersey and Pennsylvania. Next, we did 2 ANOVA tests. The first one has a null hypothesis suggesting temperatures are evenly distributed among all HUC sites. The alternative hypothesis is thus temperatures are not evenly distributed among all HUC sites. The results are shown near the top. And since the p-value is extremely small for a large f value, we rejected the null hypothesis. The second ANOVA test has a null hypothesis suggesting the concentration of nitrates is evenly distributed among all HUC sites. And the alternative hypothesis is the concentration of nitrates is not evenly distributed among all HUC sites. The results are shown on the top. And again, since the p-value is extremely small for a large f value, we rejected the null hypothesis. I'll pass on to Connor.
Alrighty, guys. So now I'm going to jump into the main point of our project, was trying to model the species intolerability, which shows how many species find the current water quality to be endangering their populations. So we first tried to look at different variables against the species intolerability, and trying linear regression did not work. The R-squared values just were not there. So we then went back and tried each value with a quadratic regression, a little bit stronger, but again, an R-squared of about 3.135% is not what we are looking for. So we then ventured into a multi-value regression method using general additive modeling. And in this format, we were able to create a model using all 6 of these water quality variables to then see how well we can estimate the variance within the species intolerability. As you can see here, they were all had a significant effect on the variability within the species intolerability, and ranking by the F values, we can see that total phosphorus had the greatest effect on the biodiversity, followed by nitrates, pH, temperature, conductivity, and last with the least effect, dissolved oxygen. Now coming into the conclusion of our results, essentially we were trying to look at how strong of an impact water quality has on future biodiversity. If you think about how if there are a greater percentage of species which are intolerable to the water quality, in the future there will be less and less populations of these species, thus less biodiversity, which is not what we want. We found that the most significant inference would be compared to the nitrate concentrations. And this is because the nitrate concentrations had the highest number of measurements that were far outside of the acceptable range. Because of this and the negative impact that they have on the fish species, we found that this nitrates are the most harmful things to US water. And these high levels of nitrate in the water can be a result of runoff from fertilized soil, wastewater, landfills, septic systems, and general urban drainage and pollution. So thank you for listening, and reduce your fertilizer use.